All right, another special case of proportional growth, or in this case, proportional decay, is half-life. So I think you guys have worked with half-life in the past, maybe in a science class or another math, but half-life is the number of years or the time period required for half of the atoms in a sample of a radioactive material to decay. So every time you're answering what is a half-life, you are answering an amount of time, okay? And it's always for the time that it takes for it to decay to half of the original amount. These elements listed with their half-life, I think you might need to reference that at homework, so in case it doesn't feel like you have enough information, don't forget that you have that. So it says 10 grams of plutonium isotope blah 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 were released in a nuclear accident. How long will it take for the 10 grams to decay to 1 gram? All right, and so we are going to start with our general solution, okay, and that is y equals a times e to the kt. And here's what it says. 10 grams was released in a nuclear. So this 10 grams is happening at t equals 0. And so I can use that real quick to go ahead and put into here. And I get 10 equals a times e to the 0, or just a. And so I know right away, okay, that part of my particular solution will be y equals 10 e to the kt. And now I have to figure out how to get the k value before I can answer the question. Okay, so I need to make it particular. Well, the thing that I know about this is the half-life is 24,100 years. Okay, so I know that I'm going to have a y value of half of my original amount, which is 10. So I'm going to have 5 grams when t equals that 24,100. Okay, so I can use that to figure out my k value. So I'm going to have 5 equals 10 e to the k times 24,100. Okay, and so the first thing I'm going to do is isolate the e, so divide both sides by 10. You do get 1/2, which maybe isn't that big of a surprise because it's half-life. And then I need to solve for that k value. So natural log of 1/2 equals the natural log of that e thing, which is going to leave me just the 24,100 times k. And so k equals natural log of 1/2 over 24,100. Okay. Certainly, it might be a good idea to store this in your calculator. Okay. If you do that, make sure that you actually store it. Do not use it a rounded value. Okay. So we're going to say let k equal this. Be stored on the calculator. So every single time that I write k in the future, we know I'm referring to this. Okay, so basically you have y equals 10 e to that kt, and I've solved for k. Right, and now the question is, how long will it take for the 10 grams to decay to 1 gram? And so basically the question is, what is t when y equals 1? Okay, you're expecting it to be a pretty long time, right? Because it's done several half-lives at that point, and so you should have an idea. It's definitely more than 24,000, for instance. So just to kind of help yourself do some estimation. So if I do 1 equals 10 e to the k, and remember that's an actual number that we know, it's 1/10 equals e to the kt. Go ahead and do natural log of both sides. And the time must be natural log of 1/10 divided by that k value. This is something you can just type right in your calculator as long as you have k stored, right? And you end up with 80,058.467 years, which is a long time.